All right, deep divers, buckle up. What if I told you that the very fuel powering our world, the stuff we dig out of the ground, holds a secret? A secret so ancient and so mind-bending, it could completely flip our understanding of Earth's history. We're talking about coal. Boring, right? Wrong. This is definitely not your grandpa's dusty old geology class. This is where lumps of black rock become like a timestamp to a global catastrophe. An event mirrored in ancient accounts, narratives across cultures, even the Bible that might just be staring us in the face every time we, flip a switch.
Indeed. Imagine a world-altering event so profound, its signature is etched not in some ancient scrolls, but right there, in the very strata beneath our feet. Today, we're taking a deep dive into an extraordinary theory that challenges, well, pretty much everything you thought you knew about how coal formed. And frankly, how quickly our world can change. Prepare for some aha moments that might just have you looking at a piece of coal with entirely new eyes.
Because it's not just about rocks, is it? It goes deeper. It's about what we believe about the past and what that actually means for our future. Let's unpack this. So today's mission, should you choose to accept it, is a mind-blowing, really open-minded exploration into a truly fascinating theory that coal, this everyday fuel, actually serves as powerful geological evidence for a global flood event. We've gathered some truly captivating sources. Stuff from geological research that directly challenges the conventional views on coal formation, to surprising scientific findings about microscopic details within the coal itself. These aren't just dry academic papers. They're more like detective notes from Earth's ancient past, presenting some truly compelling arguments.
And our mission, purely and simply, is to explore these arguments and the evidence without judgment. We're here to make these complex ideas accessible, hopefully thrilling, and maybe even awe-inspiring. We want to connect the dots between geological observations, scientific experiments, and, those ancient narratives. We want to see where these threads lead us. And trust me, they lead to some pretty extraordinary places that might make you rethink a lot of what you thought you knew about our planet's history. It's like stepping into a time machine, but the fuel for that journey is, coal.
That's the perfect way to put it. It really does challenge everything. So, okay, for those of us who perhaps haven't thought about coal since high school geology, what's the school book story we were all basically taught about how it forms?
Right, the classic school book story, the one ingrained in most of us, paints a picture of extreme slowness and tranquility. Imagine these vast, quiet, stagnant swamps, much like, say, the Florida Everglades or the Mississippi Delta today, stretching for immense distances. In these ancient wetlands, plants grow, they die, and their remains slowly accumulate, layer upon layer, decade after decade, millennium after millennium. Then, over literally millions of years, these layers of decaying vegetation get buried under sediment, compacted by the weight above, and gradually transformed into what we know as coal. It's a very neat, tidy, and incredibly slow process.
Right, the classic swamp theory. It sounds logical enough, I guess, if you're thinking about things happening at today's pace. And this idea of slow, gradual change over eons, that has a name, doesn't it? It's like a cornerstone of conventional geology.
It absolutely is. That familiar narrative is built on a foundational geological principle called uniformitarianism. Essentially, it's the idea that the geological processes we observe happening today, slow, gradual erosion, deposition, volcanic activity, and so on, are the same ones that operated in the past. This principle underpins the entire long-age perspective of Earth's history. It suggests that everything we see was formed by these subtle, ongoing processes over vast eons. It's the whole idea that the present is the key to the past.
Okay, let's unpack that. Sounds pretty set in stone, pun intended, right? But here's where it gets really interesting. Some geologists, actually committed to this uniformitarian view, looked at the sheer volume of vegetation on Earth today and said, wait a minute. Even if all this turned to coal, it wouldn't be enough. Their initial conclusion was a resounding no. They claimed that all the modern vegetation would only amount to about, 1-3% of the known coal reserves on Earth. So they actually used this as an argument against a single global flood being the cause. Say you need something like 33 Noah's floods, staggered over immense periods, to generate all our known coal beds.
Yeah, and what's fascinating here is how new research can completely flip an established objection like that one. That initial calculation, while based on valid estimates of today's vegetation volume, was operating on an outdated compaction ratio. Older models assumed you needed about 12 meters of vegetation to produce just 1 meter of coal. Think of a giant stack of leaves and how much it shrinks down. However, Modern research, including direct observations from coal geologists working right inside the mines, for example, looking at how coal compacts around specific clay balls within the seams, suggests that far less vegetation is actually needed. We're talking less than 2 meters of vegetation for 1 meter of coal, possibly even closer to a 1.1 ratio in some cases.
And 1-to-1 ratio, seriously. That's a huge shift in thinking. That single revision instantly makes a significant chunk of the world's coal reserves suddenly explainable by a much smaller, maybe faster event. It's like discovering the entire foundation of a long-held scientific objection was basically built on a faulty measuring tape.
It truly is. This drastically changes the entire calculation. If the compaction ratio is closer to 1.1 or maybe 2.1, then today's vegetation volume alone could compact down to at least 30% of the known coal reserves, not just that tiny 1-3%. So that initial not enough plants argument already takes a pretty significant hit. But the story doesn't stop there. We also need to consider, well, the pre-flood world.
The pre-flood world. Okay, now that sounds like something out of a fantasy novel or maybe an ancient history lesson. How does picturing a different Earth, before this supposed global event, change our coal calculations?
Well, it paints a completely different picture than what we see today. Currently, about 60% of our land surface is covered by deserts or just sparse vegetation. But imagine a pre-flood world that was incredibly lush, maybe a global subtropical greenhouse. And that concept is powerfully suggested by the discovery of thick coal beds even beneath the icy wastes of Antarctica, where obviously no such plants grow today. This suggests a dramatically different global climate, possibly influenced by the waters above mentioned in Genesis, which some interpret as a water vapor canopy, maybe a daily mist instead of rain, creating a perpetually green planet. If all of today's land surface was covered with such lush, dense vegetation, that alone could account for another 50% of the known coal reserves.
Whoa, okay, so we're already up to, 80% of the world's coal just by reevaluating the compaction and imagining a much greener Earth than we see now. What about that remaining 20%? Is there another piece to this puzzle?
Indeed there is. That brings us to pre-flood geography. The conventional argument assumes the land area for vegetation growth has always been the same as today. But Genesis 1, verses 9 and 10, describing the third day of creation, implies a very different arrangement. It speaks of God gathering the waters into one place so dry land could appear. This suggests one large landmass may be surrounded by a single sea rather than today's fragmented continents. Some interpretations of the scriptural language even imply a greater proportion of land area back then, perhaps 60% land versus 40% sea, compared to today's roughly 30% land and 70% oceans. If this much larger land area was also incredibly lush, well then conclusively we could easily account for 100% of the known coal reserves.
Wow. Okay, so we've fundamentally reshaped how we think about the volume of material available. The initial not enough plants argument, the one often used against a global flood, is essentially blown out of the water, so to speak. When you reevaluate the compaction, consider a dramatically different pre-flood world and potentially a lot more land for super lush growth.
Yeah.
But hold on, there's another fascinating way to look at this, something about energy, right? Because coal is fundamentally stored energy.
Precisely. If we compare the stored energy in vegetation with that in coal, the numbers are equally compelling. Mary Archer, who's an international authority on solar energy, noted in the Journal of Applied Electrochemistry that the solar energy falling on Earth in just 14 days is equivalent to the known energy of the world's entire fossil fuel supply.
14 days. Okay.
Yeah, just 2 weeks of sunshine. And she also stated that only about 0.03% of that solar energy is typically stored as chemical energy in vegetation through photosynthesis.
Okay, my brain is trying to do the math here. So if you take 14 days of solar energy and only 0.03% gets stored, that seems like a really tiny fraction, but how much plant growth does that actually equate to?
Well, when you run the calculation, taking 14 days and dividing it by that 0.03%, you get approximately 46,667 days, which works out to be about 128 years. What this means is that only 128 years of plant growth at today's rate and volume would be required to provide the energy equivalent stored in all the world's known coal beds.
Only 128 years.
That's it. And considering the period between creation and the flood, which is estimated to be around 1,600 years in some biblical chronologies, there was more than ample time for such plant growth to occur, far more than enough to account for all the energy stored in the coal.
So whether you look at the sheer volume of vegetation, factoring in a dramatically different pre-flood Earth, or you look at the energy stored in those plants, the argument that there wasn't enough time or material for a single global flood to create all the coal we have, it just doesn't hold up, according to these sources. It's like finding a treasure chest and realizing the impossible lock actually had a very simple key that was right there all along. But that's just the beginning of the plot twist, folks. You are definitely going to want to stick around because the physical evidence within the coal itself, that's where things get truly wild, and the whole swamp theory really starts to spring some serious leaks. All right, let's put on our detective hats. We've just seen how new interpretations of data can kind of dismantle the argument that there wasn't enough plant material or time. Now let's get into the nitty-gritty, the actual physical evidence found inside these coal deposits, because this is where the swamp theory really starts to hit some serious snags.
Okay, our journey takes us to a truly epic location, the Latrobe Valley in southeast Australia. This place is quite literally a monument to this geological mystery. Here you find these immense brown coal deposits, thousands of feet thick, stretching for hundreds of kilometers, some even continuing far under the ocean. When you see the massive bucket wheel excavators, I mean, they look like something out of a sci-fi movie, just dwarfed by these seams. They dig up something like 60,000 tons of coal every single day. You get a visceral sense of the sheer unimaginable scale of buried vegetation. These deposits are so enormous they extend right into the continental shelf, even linked to the crude oil found under Bass Strait.
That's just mind-boggling. I mean, we're talking about a volume of plant material that just beggars belief.
Yeah.
And you're telling me this is supposed to be just a regular old swamp. As our sources rightly point out, no one alive today has ever observed such a process. So if it wasn't a swamp, or at least not a swamp as we understand it, what was it? And what should we find in a swamp that we don't find here?
Well, this leads us directly to the proposed catastrophic explanation. The sheer quantity and distribution of these deposits are entirely consistent with a global flood event uprooting and burying the entire pre-flood biosphere. Instead of slow accumulation, we're talking about an event of unparalleled devastation that rapidly transported and buried vast quantities of organic material. Let's look at the clues.
Okay. So if these were supposed to be swamps, what should we find? And what do we actually find that throws a big wrench into that tidy swamp narrative? Give us clue number 1 in our geological history.
Clue number 1 lies at the very base of these massive coal seams. If plants grew and accumulated in a swamp for millions of years, you would absolutely expect to find evidence of the soil they grew in, right? With roots penetrating that soil. But that's not what we see. Instead, there's often a knife-edge contact between the coal and a thick layer of incredibly pure kaolin clay. This clay is so pure, it's actually pottery grade. And crucially, there are absolutely no roots penetrating this clay layer. None. It's almost as if the plants didn't grow there at all, but were simply laid down on top of it. This lack of in situ soil immediately contradicts the swamp theory.
No roots in the soil beneath the supposed ancient swamp. That's a huge red flag right there. It's like finding a perfect stage set for a play, but the main actor is missing. It just doesn't make sense. What else did these geological detectives uncover?
Next up, we have distinct ash layers that run horizontally through the coal. Now, imagine a volcanic eruption dropping ash into an active swamp environment. What would happen? Well, the swamp plants would quickly recolonize, their roots would churn through the ash, biological activity would obliterate the delicate volcanic texture, or turn it into a muddy soil, right? But in these coal deposits, the ash layers are often pristine, perfectly horizontal and distinct. Sometimes they even contain delicate glass shards. This strongly suggests rapid, massive burial that prevented any biological reworking of the ash. It points to quick deposition and covering, not slow, gradual swamp accumulation.
Okay, so not only no soil under the coal, but the ash in the coal looks like it was just dumped and covered super fast, not slowly integrated over time. And speaking of what was growing, or supposedly growing, what about the plants themselves? If these were swamps, we'd expect swamp plants, right? Cattail, cypress trees, that kind of thing.
Yeah, you'd think so, wouldn't you? But this is another really significant piece of the puzzle. The vegetation found in the coal is largely not swamp-tolerant. Not at all. The majority of the plant material in the Latrobe brown coal came from conifers, think stately pines, spruces, and cedars genera like Araucaria, Agathis, Ligaristrobos, Phalocladus, and Podocarpus. Take the kauri pine, Agathis robusta, for example. It grows up to 50 meters tall, and it prefers well-drained, deep, moist soils, often on the drier margins of rainforests. It certainly does not grow in waterlogged swamps. Even plants like the celery top pine, Phalocladus asplenifolia, prefer cool, moist, well-composted soil in protected, semi-shaded positions, not stagnant, waterlogged conditions.
Wow, so we're talking about mountain rainforest plants, maybe coastal forest plants, not bog plants, forming these immense coal beds. That's like finding a coral reef fossil on top of Mount Everest that completely upends the expected environment.
Exactly. And it's not just conifers. Non-conifers like casuarina, banksia, and nothofagus, which are beech trees, are also present. Most of these species prefer well-drained conditions, with many Nothofagus varieties found at high altitudes, sometimes 1,000, 3,000 meters above sea level. This mix of vegetation strongly suggests that the plants were swept together from a vast, diverse geographical area, perhaps entire continents of forests, not grown in situ in a slow-forming swamp.
This picture is getting clearer and clearer. It's a compelling case.
Yeah.
What about the state of the trees themselves within these coal seams? Are they neatly arranged, like they just fell over peacefully?
Not at all. We find large, broken tree trunks randomly distributed and oriented throughout the coal. These aren't just small branches. We're talking about huge pieces of wood, often snapped and jumbled together. Even advocates of the swamp theory have reportedly wondered how such large trees could have possibly gotten adequate root hold in a very soft organic medium, like a swamp, and how their roots could have breathed underwater. This disoriented, broken material just screams fierce and rapid transportation by water, not slow accumulation over thousands of years in some calm, shallow swamp. It's like a colossal logjam, but underground and turned to coal.
It really is like a snapshot of a violent, chaotic event, just frozen in time.
Yeah.
What about the smaller organic material, the really fine stuff like pollen?
We also find these incredible pollen-rich layers, sometimes up to 0.5 meter thick, almost entirely composed of pollen. Imagine the hay fever. This isn't gradual accumulation. It makes far more sense that this pollen was washed and sorted by flowing water, which then dumped vast quantities of it in specific layers. The idea of such thick, pure pollen layers accumulating slowly in a coastal swamp over long periods without being dispersed or degraded, it just doesn't add up. It points to a rapid concentration and deposition process by water.
And finally, a detail about what's left after the coal is burned. It's like the final piece of evidence in our detective story, the smoking gun, maybe.
Maybe. When Latrobe Valley brown coal burns, it leaves very little ash behind, ranging from a remarkably low 1.5% to maybe 5%. This is significantly less than the 3% to 18% ash typically found in peat, which is supposed to be the precursor to coal in the swamp theory. The low ash content is consistent with vegetation being transported and washed by water, which would remove much of the mineral content, rather than simply lying in a stagnant swamp for tens of thousands of years, accumulating sediment and debris. Cleaner coal implies a cleaner, maybe faster formation process.
These aren't just minor details, are they? It's like finding a smartphone inside a dinosaur fossil and being told it's just a really weird rock that formed gradually. The pieces just don't seem to fit the slow and steady story for many researchers. The uniformitarian geologist, the one committed to slow and gradual processes, must then invent these incredibly precise and prolonged geological conditions. Like a swamp, slowly subsiding at exactly the rate of vegetation accumulation for tens or hundreds of thousands of years, just to make the swamp theory plausible. And they have to assume this incredibly precise scenario could happen over areas hundreds of kilometers wide and even under the ocean. That's, frankly, ridiculous in the extreme, as one source puts it. It seems like asking for a scientific miracle just to maintain the status quo. And speaking of not fitting, the sheer scale of these deposits also presents a huge problem for the swamp theory. The implications are enormous. But before we get to those implications, and trust me, they are mind-blowing, if you're loving this deep dive into Earth's most explosive secrets, please make sure you hit that like button, subscribe to the channel, and maybe even consider joining our membership community for even more exclusive content. We've got so much more to uncover, so stay tuned, because what we're about to talk about radically reshapes our understanding of Earth's timeline itself.
Right. So if the conventional swamp theory struggles so profoundly to account for these many observations, the volume, the plant types, the lack of soil, the ash layers, the broken trees, the pollen, the low ash content, what's the alternative hypothesis? The other explanation is, well, a global catastrophe. An event that could rapidly assemble and process such vast quantities of material.
But how quickly could something like this happen? I mean, we're always talking about millions of years, right? That's what we've always been told for coal formation. It's practically ingrained in our understanding of geology.
That's a crucial assumption that modern research directly challenges. It has actually been known for many years that the most important factor for coalification, the process of turning plant matter into coal, is actually temperature, not time. The higher the temperature, the higher the degree of coalification, or the rank of coal produced. In fact, some studies even show pressure slightly retards the chemical reactions involved. It slows them down a bit. This is a significant finding because it means the millions of years isn't a strict requirement for the transformation itself. It's not about waiting, it's about heating.
So time isn't the magic ingredient, it's heat. That's quite a shift. And can we actually see this in action in a lab? Can we speed up millions of years in a test tube?
Absolutely. Laboratory evidence strongly supports this. For example, Argonne National Laboratories reported that relatively mild temperatures, just between 150 degrees C, that's 302 degrees Fahrenheit, are enough to produce brown coal. They did it with lignin, which is the tough, woody part of plants, water, and acidic clay in a sealed container in just 2 to 8 months. Think about that. Months, not millions of years. Higher temperatures, say up to 400 degrees C, 752 degrees Fahrenheit, can produce material with the chemical bonding of the most altered black coal anthracite. The brown coals of the Latrobe Valley, being less coalified and still containing original moisture, suggest they weren't heated to the same extreme, but the principle holds. Heat is the accelerator.
Okay, so if coal doesn't necessarily take millions of years to form, I mean, these massive amounts of plants that clearly don't belong in a swamp, how would such high temperatures occur globally, as would be needed to create all this coal during a global catastrophe? Where does that kind of planet-wide heat actually come from?
That's where the biblical account offers a potentially compelling piece of the puzzle. Genesis 7.11 mentions the sources of the great deep burst forth. Many who interpret this literally believe it implies intense volcanic and tectonic activity during the flood event itself. This massive geological upheaval, subterranean water bursting forth, crustal plates shifting rapidly, would release vast amounts of heat from the Earth's interior. This provides the necessary conditions for rapid coalification on a global scale. It's an internal heat source, rather than just gradual burial over time, that would drive the transformation, turning vast quantities of buried vegetation into coal in a dramatically short period.
So if coal doesn't take millions of years to form, and you have these massive amounts of plants that don't belong in a swamp, how does a global flood actually explain all this? Can you paint us a vivid, almost cinematic picture of the sequence of events?
Well, according to this catastrophic flood theory, we would envision a really dramatic, almost unimaginable sequence. First, immense quantities of vegetation from vast geographical areas, including those mountain rainforests and lush pre-flood landscapes we talked about, would be violently uprooted by powerful surging floodwaters. This mass of organic material would then be transported over significant distances, like colossal rafts of debris floating on a churning ocean.
So not just individual trees falling in a localized storm, but entire biospheres being ripped up and moved potentially across continents. Wow, a planetary reset.
Precisely. This uprooted vegetation would then be buried rapidly, not slowly, under massive volumes of sand and mud deposited by the turbulent floodwaters. This quick burial would be absolutely crucial, as it would prevent decomposition by keeping oxygen out. The sheer volume of overlying sediment would then quickly compress the vegetation, setting the stage for the heat-driven coalification process.
And what about specific locations like the Latrobe Valley Basin in Australia? How does that fit into this global picture of a planet being dramatically reshaped?
Well, the Gippsland Basin, which contains those Latrobe Valley coal measures, is thought by proponents of this theory to have been filled during what's termed the recessive stage of Noah's flood. As the floodwaters began to recede steadily off the Earth, they would have deposited vast amounts of sediment, including these thick layers of organic material, particularly around the edges of the emerging continents. These receding waters, initially flowing in broad sheets, would later divide into wide channels, eroding flat surfaces and forming the large valleys we see today. Our modern rivers are seen as mere trickles compared to that ancient, powerful flow that carved the landscape.
So the very shape of the land, even our river systems, could be a lingering echo of these receding floodwaters. It's like the Earth itself has a geological memory of this event. What happens after the deposition and burial, as the world starts to settle?
Following the deposition, subsequent Earth movements, perhaps as the continents continued to shift and stabilize after the flood, would horizontally compress these coal measures, folding them into broad, gentle structures. And here's another key detail often pointed out. As these sediments were folding, the tops of these folds appear to have been sliced off. This is seen as consistent with erosion by those broad sheets of receding floodwaters, suggesting that the erosion happened concurrently or very soon after the folding, not millions of years later. The world was still extremely dynamic.
It's like the Earth was still moving and settling, and the floodwaters were carving its new face, all at roughly the same time, an incredibly rapid and synchronized sequence of events. And what about the new life, the plants we see today? How does that emerge from such, devastation.
After the land eventually dried, new plants would sprout from the scattered clumps of vegetation, cones, and seeds left on the surface by the receding waters. This explains why the modern Australian flora, for instance, is similar to the plant types found in the coal buried during what's seen as the final stage of the flood. It's a massive recolonization event, basically starting fresh from the remnants of the pre-flood world.
It paints such a vivid, almost cinematic picture, doesn't it? A planet-wide reset, with the raw material for our industrial age being laid down in what amounts to a geological blink. But if that's not mind-blowing enough for you, wait until we talk about tiny microscopic halos found inside the coal. These halos tell an even more astonishing story about time itself, because sometimes the smallest details hold the biggest secrets. You know, sometimes the most crucial piece of a mystery, the thing that cracks the whole case, is solved by the smallest, most overlooked detail. Get ready for the ultimate tiny detective, radio halos. These microscopic anomalies are like little cosmic clocks, and they've been found in coalified wood, hinting at a much more recent and catastrophic past for our planet than usually thought.
Okay, so what exactly are radio halos? Imagine microscopic, perfectly spherical, discolored rings embedded within minerals, like mica in granite, but here we're discussing them in partially coalified wood. They form when alpha particles, which are emitted from a radioactive nucleus, the center of the halo, travel outward and damage the surrounding material. The damage creates a discolored ring right where these alpha particles stop. And because all alpha particles from a specific decay reaction have the same energy, they stop at the same precise distance, forming a perfect sphere around the central nucleus.
Okay. So each radioactive element leaves a unique microscopic fingerprint, almost like an atomic bullseye target.
Precisely. The number of rings indicates the parent radioactive isotope. For example, uranium-238 creates 8 distinct rings because it has 8 alpha-emitting elements in its decay chain down to lead, but other isotopes create fewer rings. Polonium-218 creates 3 rings, polonium-214 creates 2, and polonium-210 creates just 1 single ring. By counting these rings, scientists can identify which isotope was originally at the core. It's like a tiny geological barcode telling you what was there.
Okay, got it. Now, researchers made an astonishing discovery. They found these tiny halos in partially coalified wood from uranium mines in the Colorado Plateau in the western United States. And these formations, by conventional radiometric dating, are typically considered to be between like 55 and 245 million years old. A huge range, but all very old. So what did they find in this seemingly ancient wood that makes us rethink time itself?
This is where it gets truly incredible, really paradigm challenging. The vast majority of the halos found in this coalified wood were single-ring polonium-210 halos. And here's the kicker. Polonium-210 has a ridiculously short half-life, just 138 days. That's less than 5 months. If these logs had been sitting around for millions of years or even just a few decades, all the Po-210 would have vanished long ago. It decays away completely in just a few years. And its parent isotopes in the uranium chain, like Po-214 and Po-218, have even shorter half-lives, milliseconds to minutes. They're gone in a flash. So for these single-ring Po-210 halos to exist without evidence of their longer-lived uranium parent, it means uranium and polonium-rich radioactive solutions had to flood into the wood, form the halo, and do it fast within about a year or so before the Po-210 itself decayed away.
Hold on. So the radioactive material had to rush in, do its damage, creating the halo, and then essentially disappear, all within a few years. It's like a radioactive hit and run, but it completely contradicts millions of years of supposed geological time.
And it gets even more remarkable. Many of these halos were found to be elliptical, not perfectly spherical. Now, this isn't just a quirky observation, it's profoundly significant. It means that the halos initially formed as perfect spheres, but then the wood was rapidly compressed and flattened, physically distorting these perfect spheres into ellipses. This implies immense, rapid pressure acting on the wood after the halos had formed, squashing them.
That's a huge clue right there. The halos formed, then the wood was squashed. Fast. It's like finding a perfectly round pie that someone then sat on, exactly the sequence of events. Squash marks don't just appear.
And it gets even more compelling. Some samples contained both spherical and elliptical Po-210 halos within the same piece of wood. This means that polonium-210 continued to decay and form new spherical halos after the wood had already been compressed and the older halos squashed into ellipses. This scenario implies that the entire process, the rapid impregnation of the logs with radioactive solutions, the formation of the halos, and the rapid compression of the wood, all happen within an incredibly short window. We're talking less than 4 years for the Po-210 decay, and likely much, much less for the impregnation and compression to happen in sequence and even overlap.
Okay, let me get this straight. Massive trees ripped up, buried deep, saturated with radioactive solutions, tiny halos form, and then, while the polonium is still actively decaying, the wood is squashed under immense pressure, all in a few short years. And get this exact sequence occurring in 3 different geological formations. Formations traditionally separated by hundreds of millions of years from the Eocene way back to the Triassic is, frankly, simply an incredible scenario if you believe in slow, gradual processes. It seems far more reasonable, based on this evidence, to infer that these events occur during a single, unique, catastrophic event that rapidly deformed the Earth.
And there's yet another piece of evidence related to these same samples that further supports a dramatically shorter timescale. When researchers carefully analyzed the uranium halos in these same coalified wood samples, they observed a significant amount of uranium-238, which is the parent isotope. However, they found almost no lead-206, which is its stable daughter product at the end of the decay chain.
Okay, wait. So if these samples were millions of years old, as conventional dating suggests, the uranium should have decayed into a lot of lead by now, right? It's like finding a brand new battery in a car that's supposedly been sitting in a garage for 1,000,000 years. Something's not right.
Exactly. Think of it like a very, very slow clock. Uranium-238 decays into lead-206 with a half-life of about 4.5 billion years. If that clock has been running for, say, 50 million years or 200 million years, it's waste product. The lead-206 from the uranium decay should be easily measurable, it should be abundant, but here we found the parent uranium ticking away and almost no daughter lead. It's like finding that million-year-old car with a full tank of gas but virtually no mileage on the odometer. This absence of lead, using the very same principles scientists use for radiometric dating, points to an age of not millions but just a few thousand years. That's a huge, huge discrepancy. And here's a real kicker. Similar results, this lack of expected lead, were found consistently across all 3 supposedly different age geological formations. This points to them all being roughly the same, remarkably young age.
So what does this all mean then, taken together? The radio halos don't just poke a few holes in the long ages theory for these formations. They seem to completely shatter it. They point instead to a single, unique, catastrophic event, like a global flood that happened perhaps just a few thousand years ago. It's like the Earth itself is whispering its true story through these microscopic cosmic rings. And what's truly fascinating is what this might imply for us, for humans, and maybe even for any advanced intelligence like an AI, seeking to understand our planet's past purely from the data.
Exactly. When we connect all these dots, the immense quantity of coal, the non-swamp vegetation types, the evidence for rapid formation from laboratory experiments, and these frankly mind-bending radio halo discoveries coal becomes something much more than just fuel. It becomes a powerful geological phenomenon that points strongly towards a global catastrophe. It's no longer just a black rock we burn for energy. It potentially becomes a stark memorial to the flood of Noah, bearing witness to a radically different interpretation of Earth's history. It really forces us to ask some tough questions about our underlying assumptions.
It's like finding a giant fossilized monument to an event humanity has maybe almost forgotten, but for the stories, the legends. And it makes you wonder, why does this challenge our standard understanding of science so much? It's not just about a different timeline, is it? It feels much deeper than that.
No, you're right. It's profoundly deeper than just numbers on a calendar. This perspective directly challenges the philosophical commitment to uniformitarianism in geology, which we discussed earlier, that deep-seated assumption that slow, gradual processes over vast eons are the primary drivers of geological change. This alternative, based on these kinds of observations, proposes catastrophism, the idea that major geological features can be formed rapidly and intensely during short, powerful events. It asks science to seriously consider the possibility that what we observe happening slowly today isn't the only or even the primary way the Earth has been shaped. It's a challenge to look at the evidence and be willing to potentially change the framework, rather than trying to force the evidence into an old, maybe inadequate framework.
It really boils down to being radically open-minded, doesn't it? The idea that what we've been taught, what's considered settled science, might not be the whole story, and that new data, new interpretations can completely change the picture. This isn't just about rocks, it's about the very nature of scientific inquiry itself, and our willingness as humans to question long-held assumptions, especially when confronted with evidence that just doesn't comfortably fit the dominant paradigm. It's about intellectual humility, maybe.
And if we expand our perspective even further, think about the broader cultural and historical context. Ancient myths and legends from numerous cultures across the globe, from the Babylonians to the Aztecs, from indigenous Australian tribes to Nordic sagas, they all speak of a great flood that wiped out almost all humanity. The Bible also speaks very clearly of a global flood. Could these surprisingly universal legends, these echoes in humanity's collective memory, be more than just exaggerated accounts of local floods? Could they be the distant, perhaps fragmented memories of a real global event that left its indelible mark not just on human consciousness, but also on the very geology beneath our feet, like in these coal beds?
And just thinking about it from a different angle, for an AI, processing this data would be absolutely fascinating, wouldn't it? Imagine an AI analyzing these geological facts, these updated compaction ratios, the specific plant types, the pristine ash layers, the broken trees, the pollen concentrations, and especially the incredibly precise timing constraints from the radio halo evidence. All without any pre-existing human philosophical biases towards uniformitarianism or long ages. Just looking purely at the evidence. What conclusion might it reach about Earth's past? It really forces us to confront our own biases and what we choose to believe about our world's history, doesn't it? It suggests that perhaps the simplest explanation that fits all the data, in this case maybe a global catastrophe, is the most powerful one. An AI might just look at the data stack and say, yep, looks like a massive rapid flood event to me.
So, here's a final thought to leave you with. If coal, a substance so fundamental to our modern world, carries such a profound and apparently rapidly formed signature of a global catastrophe, what other everyday geological features might be silently telling us a radically different story about Earth's past? A story far more dynamic, maybe far more recent than we've generally been led to believe.
The deep dive continues, and the Earth, it seems, always has another secret up its sleeve, just waiting for us to dig a little deeper. Until next time, keep digging, keep questioning, and keep wondering. What stands out to you from today's discussion? Let us know.